All right, picture this. It's 2006, and we are looking at a massive, high-stakes tech mystery involving the dramatic rise and catastrophic collapse of an absolute internet giant. But look, we aren't just taking a trip down memory lane today. Buried deep inside this multi-million-dollar failure is a direct, incredibly urgent warning for modern project managers, especially those of you who are rapidly integrating AI into your workflows. Welcome to this explainer. We're going to unpack exactly what went wrong back then, and more importantly, how you can stop your own team from walking right into the exact same trap today. Let's get into it.
To really grasp the scale of the warning here, you have to consider this staggering number. $545 million. As you can see from the News Corp acquisition data we pulled, back in 2006, MySpace was the undisputed king of the internet. It wasn't just the most popular social network, it was literally the most visited website on the entire internet. Rupert Murdoch's News Corporation bought it for a whopping $580 million. But fast forward just 5 years, they sold it off for a mere $35 million. That is a colossal $545 million write-down. So what actually happened?
Okay, let's dive into this, because the story you've probably heard, it's really not the whole truth. There's this public myth, heavily shaped by left-leaning tech journalists at the time, that suggested Facebook simply had a superior product vision, they had a cleaner design, they enforced real names, and that's why they won. But when we look at the engineering reality, based on some fantastic forensic reporting from The Atlantic and The Verge, we get a completely different story, straight from the actual engineers who are in the trenches.
The devastating truth is captured perfectly in this quote from those retrospective accounts. MySpace didn't lose to Facebook's product. MySpace lost to its own codebase. Now, obviously, News Corp had every incentive to publicly blame their massive financial loss on fierce competition, right? I mean, it's a much easier pill to swallow than admitting to a catastrophic internal failure. But the internal engineering data absolutely proves that the platform was already locked in an unmanageable technical debt spiral long before the market fully shifted over to Facebook.
It all started with their foundation. Back in 2003 and 2004, MySpace was built on ColdFusion and ASP. And at the time, honestly, these were completely reasonable technology choices for a scrappy little startup. But the problem was the unprecedented scale. As MySpace rocketed to tens of millions of users faster than pretty much any site before it, they just kept rapidly layering new functionality right on top of that early base. They never paused to refactor, they never cleaned up, and the result was what developers call spaghetti code. It became this incredibly tangled, undocumented mess where touching just one feature would inevitably break 3 others.
So, what does spaghetti code actually cost a company in the real world? Well, based on a 2012 interview with former MySpace engineer Moore Nauman, the difference is just staggering. For a team with clean architecture, shipping a new feature takes about 1 sprint, so roughly 2 weeks. But for the MySpace engineering team, a single feature took 4 to 6 sprints. That's 2 to 3 entire months. Think about that. Every single new feature turned into this massive code archaeology project. They suffered a crushing 4 to 6 times velocity penalty, all while their competitors were shipping at absolute lightning speed.
And this brilliantly illustrates the devastating reality of that penalty. Look at the feature gap during that crucial window of user takeover from Q3 2007 to Q4 2009. While Facebook was rapidly rolling out massive game changers, the newsfeed algorithm, their third-party developer platform, Facebook Connect, the like button, a full mobile app, what did MySpace manage to ship? A redesigned homepage, a redesigned music section, and a streaming partnership. That's it.
The end result was an astonishing 8-to-1 major feature shipping velocity disadvantage. And I want to be really clear about something here. MySpace's engineers were not untalented. They were heroically productive individuals, working incredibly long hours. But they were literally suffocating under the weight of their own architecture constraints. It is a terrifying place for any project team to be in.
So what did MySpace do? Well, they recognized this massive technical debt in 2008 and decided they had to fix it. Unfortunately, they fell right into a textbook trap. We call it the Spolsky trap. This is named after software engineer Joel Spolsky, whose foundational 2000 essay warned that the single worst strategic mistake any software company can make is to rewrite the code from scratch. And why is that? Because messy legacy code actually contains years of invisible, hard-earned bug fixes and edge case handling. When you decide to just burn it down and rewrite from zero, you throw all of that institutional knowledge completely out the window.
And watch out, this builds into just an absolute disaster. In 2008, MySpace targets an 18-month timeline to rewrite their entire platform. But wait, they still have to maintain the live site for millions of users, right? So they have to divide their engineering team. The project drags on and on.
In 2009, Facebook officially overtakes them in total users. By 2010, the rewrite finally ships, but it took over 36 months and it only has partial functionality. By trying to outrun their technical debt all at once, they effectively killed the company.
Now, you might be sitting there wondering, okay, this is a fascinating history lesson for sure, but what does this have to do with me? Well, here is the harsh reality. If you're managing a modern AI project right now, you are likely building the exact same technical debt. You are walking right into the MySpace trap.
And the hard data behind our current AI boom is pretty alarming. According to the June 2026 Glean Work AI Index, we're experiencing what's called the AI velocity illusion. Look at these numbers. The data shows that workers using AI are saving an impressive 11 hours per week on generation. Fast, right? But look at that second slice. They are losing 6.4 hours to what we call botsitting. That's the time spent verifying, correcting, and heavily massaging the AI's output just to make it actually usable. So your actual net gain is only 4.6 hours.
Which leads us directly into the performance paradox. That same 2026 Glean Index shows that while a massive 87% of organizations have eagerly adopted AI, only a tiny 13% actually report significantly better performance. Just think about that for a second. Your AI team isn't failing to adopt the tools, they are adopting them into an organizational architecture that simply hasn't been designed to sustain this unprecedented speed of output. It is a perfect, modern-day mirror of the MySpace 2006 bottleneck.
So the absolutely crucial point here is captured perfectly in this statement. Speed, without the architecture layer underneath it, is a debt instrument. Adopting AI so you can generate code, specs, and reports incredibly fast, but without having the proper organizational quality gates in place, that isn't true productivity. You are just borrowing time from the future. And eventually, just like MySpace, that massive debt is going to require a catastrophic rewrite.
So the big question, how do we safely harness this incredible AI velocity without completely destroying our codebase in the process? Well, drawing directly from a 2026 MIT Sloan study, we've got an actionable solution for you. It's called the AI Architecture Blueprint. It boils down to 3 specific, mandatory rules that modern project managers have to implement right away. Let's quickly walk through them.
Rule 1 is the Designed Review Standard. Basically, you have to stop relying on random, ad hoc botsitting. You need a formal, designed, organizational standard for exactly how AI output is reviewed and approved.
Moving to Rule 2, create a persistent context layer. You have to get your AI context out of those isolated chat threads. Your prompts, your rationale, your specs, they all must be stored in a structured, easily retrievable system so the knowledge doesn't just evaporate.
And finally, Rule 3, develop a fast discard reflex. According to the MIT Sloan findings, high-performing teams accelerate out of failure instantly. You have to be willing to toss out failing AI use cases before they have a chance to break your core systems.
Which brings us to the most important question of this entire explainer. I want you to look at your own projects, look at your own tools, and your own processes right now and ask yourself, what is the MySpace in your current AI stack? What is that one thing that looks totally fine today, but is secretly accumulating massive technical debt that will eventually crush your productivity? Audit your AI processes right now, build that architecture layer, and whatever you do, don't let history repeat itself on your watch.